In this part of the tutorial, I'm going to show you how to enter into the Manage Settings side of the application and inspect an existing Settings.JSON file to evaluate its content and decide whether it needs further editing. In order to do this, we will take advantage of the files that you should have been able to download from the Zenodo repository following the tutorial instructions. In particular, what you should have been able to download from Zenodo is a Microscope.JSON file, a Settings.JSON file, and an example image data file. So let's get started. In order to enter the Manage Settings part of the application, we will click on this button, and then similarly to what we did in Manage Instrument, we will select the tier level that we want to use for documenting the experiment we are interested in. In particular, in this case, I know that the experiment has been documented at tier 3 because the microscope is a custom-made microscope and therefore requires full documentation. So, because I know that the Settings.JSON file we are going to open is fully validated at tier 3, we can definitely select tier 3. Once we get to the next window, we can confirm that we are at tier 3 and therefore we are documenting an experiment at full documentation level. In addition, we can see that there are 3 different steps that we will have to go through in order to be able to access, inspect, and possibly edit a given Settings.JSON file. The logic is that we first select the file that describes the microscope that was used to acquire the specific image dataset we are working on. This file can be produced once and then used over and over again for documenting all the image acquisition sessions that were performed using this instrument to produce different images. So the first step is selecting the Microscope.JSON file. The second step is selecting the image that we want to document. And then the third step is to either create a new Settings.JSON file from scratch or open and edit an existing one. So let's get started. In order to go through the first step, we have 2 options. We can either import an existing file that is not already part of our application, or we can use load from the local home folder. In this case, I'm going to show you how to import the file that we wish to use and that refers to the microscope that was used for the acquisition that we want to document. So we click on Import from File, we click in this box, and we select the Microscope.JSON file that we downloaded from Zenodo. Because I have already saved this file in the specific folder I'm using for this tutorial, it is ready to be selected and opened. Once this is done, this button will be highlighted, indicating that I can proceed to the next step. Once I have done that, the app indicates that we are now performing step 2, and we can import the desired image file. Again, I click on here, find the image I want to document in the file system, and open it. You will notice that in this step, it is going to take a little bit longer for the next step to be made available. This is because the application is using bioformats to interpret the content of the header of the file and import the appropriate metadata. In any case, when the contour of this area becomes greenish-orange and this button is highlighted, we know that we can proceed to the final step. In this case, we are going to import from file the existing Settings.JSON file that was downloaded from Zenodo. So we're going to do the same thing we did for the previous steps, and we're going to select the desired settings file. When we do that, we can recognize a settings file because it is called with the name of the image, and it has an AS suffix to indicate that it contains acquisition settings. Using the AS suffix to distinguish a settings file is a convention that I use, but it is not mandatory. Everybody can use whatever convention they prefer to call their Settings.JSON file. But if you like the way I do it, you can also adopt the same method. So we are now ready to continue to the next step and enter into the main settings management window of the app. In this window, we can visualize, inspect, and edit the settings that were used for acquiring a specific image or image dataset. The first thing that I want to point out to you is the information found in this upper left corner of the window. Here you can find a short summary of the basic information about this image that are already present in this file. In particular, we can find the image name, the XY dimensions of the image, and the number of channels, time points, and Z focal planes that constitute this image. In order to see more information about the image, we can click on this button, which is called Edit Image Settings, and enter the corresponding window. At this stage, I want to take the opportunity to point to your attention that in this first window, we can see the name of the microscope that was used to acquire this image, which is written here. In addition, similarly to what happens in the Manage Instrument side of the app, the data entry windows of Manage Settings are typically subdivided in different tabs and subtabs. So, for example, in the Image tab, we can enter different general information that pertains to how this image was acquired. As an example, we have the date of acquisition in this tab, and then in these other tabs, we can associate this image with a set of different hardware components that were used during image acquisition. For example, here we can select the insert that was put on the stage to hold the slides, the focal stabilization device, and the acquisition software. In order to show you how you would proceed to associate a specific component to an image, what I can do here is delete the one that is currently selected. When I do that, I can press the plus button here, click on the menu, and the application will show you all the stage insert components that are available for this microscope. In this case, because there is only one available, stage insert, I will select and associate it with this image acquisition. I also want to show you that under the Pixels tab, you can see information that was automatically imported by bioformats and that define the structure of this image. For example, here you can find the dimension order, the XY size, the number of Z steps, the number of channels, the physical size of the pixel, and the time increment in case it is relevant. Once we click on the Confirm button, we exit back to the general view, and in this view we can see different buttons, each referring to a different section of the settings. By clicking on each of these buttons, we can edit the information about each of these different sections. So, for example, in the Edit Imaging Environment section, we can select the environmental control device that was used, in this case, during image acquisition. Similarly, under Edit Objective Settings, we can see that this image was acquired using the 60x Plan-Apo objective, and we can verify whether there are any settings associated with this objective. If that is the case, the settings can be found here. In this particular case, we have information about the temperature in which the objective was kept during acquisition. In addition, we can find the immersion liquid product name and catalog number, and some basic characteristics about the immersion liquid. However, I want to show you that, as you can see here, the selected objective is just one of the possible objectives that would be available for this instrument. So in case we want to choose a different objective because, for example, we notice a mistake, we can delete the objective we have already selected, and we can click on another objective and add it to the settings file by clicking here. This way, we can associate the specific objective with this acquisition. Because I know that the initial objective selection was correct, I'm not going to confirm here because I don't want to mess up this file. Finally, I'm going to show you another important part of the settings, which can be found by clicking on the Edit Channels button. In the Edit Channels section, you can find all the different channels that have been found by bioformats in the header of this image file, and which pertain to the channels that were used during acquisition. In this case, the Settings.JSON file is already completed, and therefore you can see that all the information here are already validated and have a corresponding green validation dot, indicating that all the required information is already present in the file. As an example, I'm going to show you how to take a look at the DAPI channel. To view this channel, we click on DAPI channel, and then we click on Edit Selected. After we do that, the application will show us a schematic representation of the light path that is associated with this channel. In particular, the light path is composed of the light source, other components, the set of filters, the objective, and at the end, the detection system, which in this case is a camera. One other thing that I want to point out is that inside these little boxes, it is possible to select other available hardware components that can be associated with the light path. Importantly, with this tool, it is also possible to arrange the components in a specific order that reflects their physical arrangement along the optical path. At this point, I want to remind you that the items that are found in this list are those that were entered already in the Microscope.JSON file when we managed it in Manage Instrument. Using this tool, it is therefore possible to select available items that were used while disregarding those that were not. If we now click on Confirm, we can exit on the general Light Path window, and by clicking on the Edit Channel Settings button found down here, we can access general information about this channel. For example, here we can modify the name of the channel. We can enter the general characteristics of this channel, and if relevant, we can enter important information about the fluorophore that was used in this case. So, this concludes this part of the tutorial. Please join us again in the next video.